Hi, in this video we're going to look at the January 2013 Higher Paper 1 question 21, and as you can see it's a three-dimensional problem. Very often in three-dimensional problems you'll be using Pythagoras' theorem, so you'll be looking for right angle triangles. We'll see that in a moment. Sometimes you have to use more than one right angle triangle within the three-dimensional problem and perhaps use Pythagoras twice. For instance, if we're looking for the length of line TP, then you would almost certainly be using Pythagoras twice, but that's not what they're looking for. They're wanting the angle between this line and the base here, this rectangular base here. Okay, now the first thing to notice is it's a rectangular base. That means that all the corners are going to be right angles. So although it doesn't look like a right angle, it's because we're supposedly looking at it from the side and slightly above, and therefore it appears not to be right angles, but that's a right angle there. Now, in order to get started in this question, if we're going to find this angle here, it'd be useful if we actually knew something about this line here, because you can see that we know the vertical line here is 15 centimeters. If we knew this length here, PM, then it'd be a simple matter of doing some trig with that, with this right angle triangle TPM. So what we need to do first of all is to use the triangle PRQ, and this is very often the way you do it, starting with these base triangles first, these base right angle triangles. So we're going to use Pythagoras for that, because PR is the hypotenuse of this particular triangle here, and in order to find PR we just work through Pythagoras as we would normally do. So PR squared, that's this line here, is equal to 10 squared, this line, plus 16 squared. So the basic layout of Pythagoras, and we work our way down and we find that the answer for the full length there is 18.88. But in actual fact what we want is half of that, because we're really interested in the line here, which is PM, and we can see that halving the 18.88 gives us an answer of 9.44. Now we have a right angle triangle here, TPM, which has this side here and that side here, and we want to find this angle in here. Now as far as this angle is concerned, that's the opposite and this is the adjacent, so we're dealing with tan. And if we have a look at the angle between these two lines, then we can find that we get it by using tan of the angle is equal to 15 over 9.44, the opposite over the adjacent. And you can see that the angle we're looking for, just to emphasize that, is between the hypotenuse and the adjacent side. We do tan to the minus 1 of the 1.59 and we get an answer of 57.8 for this angle. Now just to illustrate how we do that in the calculator, to do tan to the minus 1 you press the shift key and then the tan button, and you'll notice it says tan to the minus 1 above the tan button in orange. That goes with the orange colour of the shift key. So it's shift tan to the minus 1 and that will appear on the screen. Then you type in your number, in this case 1.59, press equals, and you get your answer. Now notice that the question does ask for correct to one decimal place. So if you put in something like 57.82, rounding it up to 2 decimal places, you would automatically lose a mark off this question right away. So we need to make sure that we only have 1 decimal place, as I have here in the answer. That's all for this particular video. Thank you for listening.